acid is cinnamic acid here. That's right. Same kind of a reaction as we saw with Mirvan. Same kind of a reaction typically. But only thing is that here cyanide is there which cannot leave the place. But carboxylic acid, definitely carbon dioxide would love to leave the place. So go for a very similar reaction. What happened here? Benzene diazonium chloride. I treated with CH2 double bond CHCN. We removed all of them. We made it a single bond here, and the CN was still available. But here, what's the difference here? I have pH, CH double bond CH, AR gets added, and the carbon dioxide leaves the place. Nitrogen leaves the place. HCl leaves the place. Okay. Let's go for the next reaction here. Benzene diazonium chloride plus zinc in the presence of mercury and HCl. What reagent is this? What is the name of this reagent? Is this called as Clemmensen reagent? Hello?
Yes.
So this is nothing but a reducing agent, right? So you can see the benzene diazonium salt, N2 plus Cl minus salt, reduction is happening here. Reduction means addition of hydrogen. So you can see this is nothing but Ar, N double bond NCl, right? So I am reducing it by the addition of hydrogen here. So add hydrogen, Ar NH2, and chlorine goes off, and nitrogen becomes ammonia. Let's go for the next reaction here. We already discussed this reaction. Benzene diazonium chloride plus phenol. What should have happened? N2 plus Cl minus OH NH. Remove the HCl. So we have para-hydroxyazobenzene. To this, one more time I am treating with benzene diazonium halide here. So this hydrogen is still available. So what happens? I am having N2 plus Cl minus. Push it off. I have N double bond N pH. One more time benzene diazonium halide is coming out. So again I can go for this reaction here. Push it off HCl. Okay, copy down the reaction. So I am discussing about the another qualitative test for the diazonium salts. Benzene diazonium chloride, when it is treated with phenol, phenol can release H+. it is having mild acidity. Since it is having mild acidity, I am treating it at the pH range of 9 to 10 so that the H plus is being lost by the phenol. As the reaction proceeds, the HCl of the benzene, this is N2 plus Cl minus, this is having OH and H here, this moves out, so that what I get is hydroxy. This is at the para position. I have hydroxy and I have azobenzene. The color of the dye is orange in color. As I mentioned you, this group is responsible for coloring in dyes, which we called as chromophores. The second reaction is with same benzene diazonium chloride, but I do it in the presence of aniline. We know this is having lone pair of electron, mild basicity is there. I don't say it is not at all basic, mild basicity is there. In order to activate it, I am doing it in an acid medium, 4 to 5 range. Again the same thing is happening. I am having benzene diazonium chloride and I have aniline. This HCl is removed. You can see you are having para-amino-azobenzene, which is yellow in color. So this marks as a qualitative test for benzene diazonium salts. Okay, da? We are discussing about another reaction of benzene diazonium salt with naphthol. This molecule is naphthalene. So I am doing alpha naphthol. So this is the benzene ring at its alpha position. The OH is present. So we call this as an alpha naphthol. You can see it is very similar to phenol. It is also having OH on the benzene ring. So I prefer to do it at basic medium. Same reaction proceeds. Here I am having benzene. I am having the second bicyclic ring, OH. As you understood, to its para position only it got bonded. Same thing here. At the para position it gets bonded. The color of the dye is orange reddish. This occurs in alpha naphthol. What will happen if I do it beta naphthol? N2 plus Cl minus, having benzene. Here the OH is at this position. This is alpha, this is beta. Now where will this HCl get removed? This position is quite available here. So what happens? At that position the reaction happens. I have N double bond N. I am having benzene here. The bicyclic ring is there. So this position it gets added and the OH is still available here. Understood both of you?
Yes, ma'am.
The color of the dye is again orange reddish. Next one, when I use aldehyde with secondary amine. See, I am having CH3CHO double bond, primary amine, RNH2 it is. I remove this. What will you form? CH3CH double bond NR. What is this compound called as? CH double bond N. What is this compound called as? This is called as imine. This compound is called as imine. Now we are discussing about enamine. What is this enamine? When C double bond C is there, to this NR2 is present. This is called enamine. For this, the reaction happens with secondary amines. So I have aldehyde. I treat. It's not necessarily only aldehyde will react. Even ketones will react. Okay. I treated aldehyde with primary amine. They will form form imine. If I treat it with secondary amine, they will form enamine. So the question comes, which is a favorable condition for the formation of enamine? Secondary amines, sterically unhindered aldehyde also should be there. Okay, sterically unhindered aldehyde and secondary amine favors the formation of enamine. Now I have aldehyde, I treat it in the presence of H+. Very important reaction. This is how the first reaction also happened, but I am just giving you the shortcut here, that's it. Okay. In the presence of H+, I am having the lone pair on oxygen which is attacked by the H+. So now what is happening? Since its lone pair is lost, you get plus OH. Now the secondary amine comes. Is it a secondary amine, Gradishram? Is it a secondary amine?
Which one, ma'am?
This one.
Yes.
Yes, it's a secondary amine. You can see only one hydrogen is bonded with nitrogen, so it's a secondary amine. Now what happens? This carbon is bonded with the oxygen that is containing the positive charge. So it is resonance, not stabilized. So what should I do? The nucleophilic attack is happening here. The nucleophile attacks the carbon and the double bond shifts over here. Now what will I get? COH and NHR2. The nitrogen lost its lone pair. So you can see it has gained a positive charge here. So it is CH3CH double bond NR2. Here it is CH3CHOH NR2 and H. Nitrogen is carrying positive charge. It is not allowed, isn't it? Because nitrogen is an electronegative element. So what happens? The H+ moves out. As the H+ moves out, again I am having the oxygen with lone pair of electron. It goes for an attack here and the nitrogen regains its lone pair. Once again the same process repeats. Which process? The oxygen is carrying positive, that is not allowed, right? So the nitrogen lone pairs gets into the bond between C and N and the bond between carbon and oxygen is cleaved. Now what will you have? CH3, CH, double bond, nitrogen lost its lone pair, so nitrogen gets plus R2. This molecule left the place. Once again it is trouble. Why? Nitrogen is an electronegative element, so it has got positive charge. So what has to happen? I have to cleave it, right? So I can see the hydrogen elimination is happening. The bond shifts in here and the double bond shifts in here. So what do I have here? CH2 double bond CH NR2. So in other words, very simply, how do I understand this? I take aldehyde, I am treating with secondary amine here. I am treating with secondary amine here, R2NH. So what should you do? Make the double bond between them and remove the water here and connect it. CH2 double bond CH NR2. Copy down. We are discussing about the synthesis of enamine. For JEE Advanced, they will be providing you in the formation of enamine. The number of steps that are followed here is or involved here. They will ask you to number the step number. Protonation of alcohol at first, and then attack of the amine, then again deprotonation of the nitrogen. Okay, write down along with the mechanism. We are discussing about Hoffman elimination, which is going to give you less substituted product. So I am taking ethylamine at first. To this ethylamine, I am treating with 3 moles of methyl iodide. This step is called as exhaustive methylation. Exhaustive methylation. See here 2 hydrogens are there. So at first I could have replaced the 2 hydrogen by 2 methyl, but still nitrogen is having lone pair. Again the methyl iodide comes for participation. This is plus, this is minus. So what will happen? Nitrogen has lost its lone pair and I have 3 methyl ion, and because of this positive charge the iodide also comes and attacks it. so that I am forming a salt here, quaternary ammonium salt. To this, they will provide you aqueous Ag2O. What is aqueous Ag2O? Silver oxide dissolved in water. Just like any metallic oxide, when you dissolve in water, what will you form? Hydroxide, metallic hydroxides, basic hydroxide, AgOH. This dissociates to form Ag plus and OH minus. I already have I minus here, OH minus is here. You know I is very easy leaving group. So again a nucleophilic substitution reaction happens. Instead of I minus, I have got OH minus here. So I am writing CH3. The hydrogen is written here for understanding. CH3, CH2, N plus, CH3 thrice, OH minus. So this H plus moves out, the bond shifts in, and this nitrogen moves along with its bond pair. So what will I have? I have CH2 double bond CH2 plus NCH3 thrice OH. So what I have formed here is an less substituted alkene. This elimination gives you anti-elimination. Here in this case, it is a symmetrical alkene. I am unable to say whether it is anti or whether it is syn. But if it is an unsymmetrical alkene, then I will be able to say whether it is anti-elimination or not. Okay? Understood the mechanism here?
Yes, ma'am.
Yes. Now copy this reaction and do this reaction on your own. That's a Gomberg reaction where you are able to form the diphenyl molecule. Benzene is becoming an. Is there any other reaction in which you formed biphenyl? Any other reaction? Ullmann reaction. I have chlorobenzene, two chlorobenzenes in the presence of copper catalyst. Remove them to form diphenyl. Ullmann reaction is also helpful in forming diphenyl. Understood, Ra? Yes. Complete this question. Nearwin reaction. Benzene diazonium chloride plus acrylonitrile. Acrylonitrile has the following structure. This is an acryl unit. CH2 double bond CH bonded with nitrile. This undergoes free radical mechanism here. Though this free radical is not that much stable free radical, but still it is formed. Okay. So this is undergoing an homolytic cleavage, so that you are forming benzyl phenyl free radical is formed here. Okay. Similarly here, break it at the middle, so I get like this. So this is undergoing bonding, benzene CH2, and this carries the free radical here. To this I am treating with copper 2 plus. Okay, I am treating with copper 2 plus. So what is happening? This is releasing one of its electron to copper 2 plus itself. What do you mean by copper 2 plus? Copper has lost 2 electron. This is one of the free radical. That means it is having just 1 electron. Okay, so this comes to 2 plus here. Since it lost its free radical, it gets a positive charge. copper 2 plus upon acceptance of electron means reduction, right? So it has went to copper plus 1 state here. So it has gained an electron to become copper plus 1. Now to this chloride ion comes into play here because this went on, right? So chloride ion comes into play so that I get CHCl. This reaction is called Meerwin reaction, where you treat free radical mechanism with benzene diazonium salt. So let's name this now. Benzene, CH2, CH, Cl, Cn, which is prior functional group to us. Obviously nitrile is there, and to the same carbon that is containing nitrile, chlorine is also present. So I gave 1, 2. So I have 1 chloro, 2 phenyl, ethane, because 2 carbon system is there, ethane nitrile. Understood, Ra?
Yes, sir. Yeah.
Complete the reaction.